Up until now, we've been adding nodes and pipes to our project, and we've talked a little bit about what a catalog is, but we're now going to look into that in a bit more detail. So if I add a manhole and a pipe between them, each of these nodes has an assigned type. In this case, it's the manhole type and a catalog, which is defined here just as manhole. Same goes for the pipe. The pipe has, in this case, a storm sewer catalog. These catalogs are sort of the fundamental components that are used to define the geometry, the criteria, and the available sizes. InterHyd is going to use this as part of the automated design, and it's also going to use those criteria to determine if there's an issue. For example, if a pipe exceeds the maximum allowable length, it's going to highlight that as an issue. And just to illustrate that, if I were to pull this out, it's now red, and when I click on it, it says my length is too long. So the catalog would define what is that maximum length. So to view the catalogs and edit them, you go up to Project and Catalogs. And now you can see here in this top box, we have all of the different catalogs that are included in this project. So for nodes, there are 3 different geometry types. We have circular, rectangular, and custom geometry, which would be things like a head wall where you're actually customizing the line work. And then under pipes, we also have a circular and rectangular pipe. Let's start with looking at a pipe catalog, in this case, the storm sewer. So I've called it storm sewer, but you might decide to call it, storm sewer for a given municipality. It's of the circular type, and we've assigned 2 materials, PVC and concrete. In this bottom section, this is where you can assign individual sizes to this catalog. So for example, for each pipe size, we can specify the material, the nominal size as it appears in the plan view or on the Excel design sheet, physical parameters like the inside diameter and the wall thickness, whether or not to draw it schematically. So in this case, schematically, it would be just drawing it as a single line. And you can see for the PVC pipes that's what we do, whereas for the larger pipes, we draw it with the actual inner diameter, so it'll draw as 2 lines. And this is where we can specify things like what is the maximum length, the minimum and maximum slope, as well as the minimum cover. And you see this can actually be edited on each individual size depending on your municipal requirements. Typically, bigger pipes can run for longer lengths and might have different slope requirements as well. If we take a look at one of the nodes, if I just click on manhole, same thing, we've specified a geometry. We've specified a default rotation. For a circular node, that won't really matter, but if you have something like a catch basin or a head wall, that's where it'll show the grip. Just like with pipes, you can define a material, and you can define your sizes down here. So for manholes, typically it's just going to be a single material, but you can specify the nominal size, the actual diameter, and wall thickness. You can also then specify what is the maximum allowable pipe size coming into that. That way, whenever the pipe gets bigger, InterHyd can automatically move the node up to the next size. You can also specify the minimum separation between pipes, which is useful if you've got pipes coming in at tighter angles. You might need to have a larger manhole to accommodate them. And then in this section here where it says node drops, you can actually specify the minimum required node drops through your manhole structures. So by default, it's saying for a pipe deflection angle. So the pipe deflection angle is if you look at the upstream and the downstream pipe, if they were straight on, that would be a deflection of 0 degrees, right? And 180 would be they're effectively on top of each other. So this is just saying a minimum drop of 0.03 meters is required at all angles. But let's say you had to differentiate different angles. You can just click add here. And we'll say the end angle of this one will be 45. And then from 45, let's say to 90 degrees, we'll have 0.06 meters. And then we can say 90 to, let's say 135 degrees will be 0.9. And in this case, you'll see I didn't put this all the way up to 180. So it actually means if the pipe deflection goes past 135, it's going to register that as an issue. And we can actually see this in action. Let me just close out of this. So if I add in another pipe here, you will see these inverts, there's a 3 centimeter drop between them. You can actually click on this and you'll see that drop there as 3 centimeters. Now, if I pass this, so this would be a 0 deflection angle. This would be about 45. And if I put it sort of past 45 but before 90, you'll notice we now have a 6 centimeter deflection angle. If I go past the 90 mark, this is now a 9 centimeter node drop. And if I go past 135, this is now flagging as an issue. And it's telling me my deflection angle is wrong. You can also come up here into results and click on the issue list, and it will tell you exactly which component has a problem and the specific issue. Okay, so coming back, let me just delete this. Coming back to our catalogs, that's how you can define different catalogs. Rectangular catalogs, it's much the same thing. And for these custom ones, what we've actually done is we've defined these optional line work. So this is just a table where you can put in the XY coordinates of the lines that you want, and it is relative to sort of the center of the component. So you can see this is defining just the simple geometry of a head wall. And just to really illustrate this here, if I click on head wall, you can see this is just a very simple schematic view of a head wall with 3 lines. And that was defined here by basically just putting this as 3 lines, right? So we're starting a new polyline and then we're adding points to that. Now, the third thing I want to see here, so we saw our node catalogs, we saw the pipe catalogs, and then the third thing is these node types. And these are the buttons that we've seen here on left side, as well as the different types that we can toggle our components. So as you can see, these are customizable. So you can change the names, the hotkeys, and the default node catalog. So that way, when you create a new type or you switch that type, it's automatically going to update based on the correct catalog and geometry. And you can also specify the default downstream pipe catalog. So let's create together a new catalog to sort of give a concrete example of what we want to do here. Let's consider, I'm just going to delete this. We're just going to pretend schematically you've got a storm sewer, and we can add in catch basins. But let's say you now need to define a rear lot catch basin. You can't just use this catch basin because it's going to use, let's say, a different geometry, and the downstream pipe will have a different requirement. So what we can do is we can define a new type. So we're going to come up here to Project, Catalog, and first we're going to define a new rear lot catch basin type. So I can copy our catch basin by clicking on Duplicate. When I open here, I'm going to rename this to rear lot catch basin. And in this case, let's say we have a circular catch basin. So I'll change that to circular. And I can change my criteria. Let's just say it's going to be a 500 millimeter diameter catch basin. So I can set my diameter. And I'll leave everything else the same. So you can see our rear lot catch basin has now been added under the circular catalog. We now want to also specify the type of pipe that's going to come out. So typically municipalities might have one set of criteria for the main sewer in the road. They might have a different criteria for catch basins and maybe a different one for rear lot catch basins, etc. So in this case, we are going to duplicate this sewer. We're going to rename this to rear lot catch basin lead. In this case, we just need PVC, right? And let's say the maximum size is a 450. So I can just click this remove button to remove all of these other catalogs. And in this case, let's say the criteria, the maximum length of our rear lot catch basin leads can only be 80 meters. So I can set that to 80. And let's say the minimum slope has to be 1 meter or 1%, but our minimum cover can be 0.6 instead of 1.2. So I can set those values. I hit OK, and you can see we now have this rear lot catch basin lead. Now the final piece of this is we want to actually create this as a new node type. So I'm going to click Add here, and it's going to add a new one at the bottom, rear lot catch basin. You can also insert in the middle or move these up and down. And we'll assign it a hotkey just for convenience. I'm going to put L. And now I can specify what the default node catalog is going to be. In this case, the node, I want it to be this rear lot catch basin. And downstream of that, so the pipe that's going to be coming out of my rear lot catch basin, I want it to be assigned to the rear lot catch basin lead. So now that I've done that, I can click close. And you'll notice we now have a new button at the bottom here, rear lot catch basin lead. So now what I can do is I can click on this and I can add it into my design. And you'll see it's now naming it rear lot catch basin lead. You'll also see that the slope here is at, let's just do that. That's at 1% compared to this one is at about 0.5%. And that's because it is now pulling by default from that rear lot catch basin lead. You'll also see that we have now constrained the sizes available to that pipe to just the 4 sizes that we have defined, unlike our storm sewer where we have many more sizes. And just to illustrate this, if I were to connect a catchment in here, let's just say 0.2 hectares. This is fine. You can see we have a 300 and a 300. But if I make this any bigger, let's say 0.5. Oh, that still works. Let's go to 1. Yeah, you can see now this line is red, and it's telling us that we have exceeded the capacity of that pipe because it's maxed out at the 450, versus downstream, this is now updated to a 600, right? Because this downstream main sewer has access to a lot more sizes. So this is just one more way where you can use catalogs and custom node types to really ensure that the design is being adhered to.